but if you use bigger nails, you're gonna have to have something underneath the cardboard for it to go into.
This one's. It's not like. Yeah, I think cardboard base is the problem here.
No, it's just not happening.
A stable base and a good grade. Don't you want
Isaiah, what's your last name?
Navarro?
Navarro.
This one's might melt the plastic. Yes, I'm telling you that it's not cold. Did you get that on film? Test number 8 with Pat.
I'm gonna go with let's go.
And that's physics. Oh shoot, it's still going. Our device start system works by taking the current from the battery and moving it through the wires to the motor, where it converts electrical energy into mechanical energy, causing the end of the motor to spin to the right, pulling the door out of the way of the marble that is being compressed by the spring against this door, shooting it down the tube, and therefore completing our system. And then as the current leaves the motor, it goes back into the battery and starts all over again till it is disconnected.
So for our mathematical explanation, we're going to go over simple harmonic motion in our contraption. So the simple harmonic motion of a spring is an example of energy transformation between potential and kinetic energy. So when a spring is stretched, it exerts a restoring force which tends to bring it back to its original length. This restoring force is generally proportional to the amount of stretch as described by Hooke's law. Potential energy is stored as a result of the deformation of an elastic object such as a spring, and it is equal to the work done to stretch the spring, which depends upon the spring constant K as well as the distance stretched. So in our contraption, when the spring is unstretched and it is compressed, the potential energy of the spring is 0, and as we turn the motor on, which releases the gate and lets the spring stretch, it is displaced by a factor of x, and this can be seen by the potential energy, which is 1/2 kx squared. And you can graph this as a sine function over time, and it would look something like this, which is going to be described by Hooke's law, which is negative kx, which is the force of the spring.
This physics class has taught me that homework is an important factor in a person's grade and that I should probably do it more often. But other than that, I really enjoyed the class and I understood most of the concepts taught to us, and I hope to further my understanding of physics in the future.
I think from this physics class I learned that it is very important to come to every single class, because you can definitely miss out on a lot of the material taught even in just one day. And I think I learned this definitely the hard way, because I had a lot of catch up to do if I ever did miss a class period. But other than that, I did enjoy this physics class, and I think a lot of the labs we did were pretty fun, and the concepts taught are applicable to life, especially if you're pursuing engineering of some sort. So I hope to take these lessons I learned and apply them in my life in college. Thank you.